Okay. What?
Everyone always talks and you have to try to find the right time to start.
All right. Need you guys listening. Okay. Reviewing from yesterday and also from Friday before break. Guys.
Yes, ma'am.
Okay, fill it in. You're doing this from memory right now. Okay, everyone have it down? I'm going to give you a quick few seconds to flip back to yesterday's notes, wherever they may be, and double check your formulas and see if you have them. You do not have to put the plus minus stuff in. So double check, see if you have them correct. If you do not, fix it. Make little notes to yourself where you messed up so you know not to make that mistake on test day. All right, which one's sign? Snobby or friendly?
Sign is friendly.
Friendly. So sine of A, cosine of B. Same sign or opposite sign? Same, so plus. And then sine of, I've already used A, so what would I put? B and cosine of A. All right, cosine, friendly or snobby?
Snobby.
Snobby. So it only hangs out with itself. Cosine A, which means the next one's going to be cosine B. And then why is it minus? Because it is the opposite. Good job. You didn't sleep in today?
No.
Thank you. All right. Minus sine what? A times sine of B. Will you hand this to him, please? Thank you. Okay, so tangent. When you write your tangent, there's no little cute story for them, but we know it's a fraction.
That's sad.
I know. We know it's a fraction, and it's only tangent. So what do we start with? Tan of A, and then this sign matches the top, so then what comes next? Plus tan of B. Thank you. And then denominator has what? One opposite would be minus. Tan A plus or times? Times tan B. All right. So as I stated before, we will be learning new formulas starting tomorrow. So you want to make sure that you've worked on these. How many of you had them good, like solid? You got them right? You had them, no problem. Good. You want to continue working on them. So test day comes, you write them down, and you're good. All right. Not number one. Let's write this down first. Solve for x such that 0 degrees is less than or equal to x, which is less than 360 degrees. Have we done this before?
Yeah, in that context.
I mean, solving with this restriction here. Between 0 and 360. Okay, number 1. sine 2x times cosine x plus sine x cosine 2x equals -1. Okay. What you want to recognize when you're doing homework or quizzes or tests is when to expand and when to condense. Do you see that this looks very similar to this one right here? Do you see that? So then you're going to go from this expanded form down to its condensed form. Okay, so when I condense it, will I condense it down to sine or down to cosine? Sine, because there's sine, cosine, sine, cosine. So sine of A plus B or minus B? Plus, because it's the same. And what is A and what is B? 2x and x. Because I'm adding, does it really matter which one I put first?
No.
If I was subtracting, would it matter?
Yes.
Yes. So recognize A is with your first sign, not your first cosine, but your first sign. So whatever comes first here with your sign, that one is your A. All right, what do we get? Sine of, what's two? They're like terms, so what do we get? 3x. Okay, we've seen this before. Do you guys remember what 3x means when we're solving? We did it last unit.
There's going to be more answers.
There's going to be multiple answers. It's when you go around a total of how many times? There's 1, 2, and then we do it 3. One more time. And then we divide everything by 3. Good job. All right, so put your thinking caps on. When is sine -1? 270. Is it just 270 in this case?
No.
Can we make 3x equal to 4?
Yes. Yes, thank you for pointing that out. When I did teach this, well, actually, I'll leave this one here. She's saying, can we write it the way we did in notes? Sine of theta equals -1 because we used the substitution. Theta equals 3x. Okay, so when is sine of what angle is -1? You guys gave it to me earlier. What is it?
70.
And that is the only place. Do you agree? So there's only one answer in this case for the first set. So this is the first set, second set, third set, where each set has only one answer. What do I do to find the second and the third set?
Go around the horn.
Right, go around. And when we go around, we're finding coterminal angles. So what do we add?
360 degrees.
360. Do that now. You should have calculators out on your desk. Okay. So 270 plus 360. Anybody have it? 630. Take that and add 360. 990. And then Darrell pointed out earlier that we divide everything by 3 because I'm going to take the theta out, and it wasn't theta to begin with. What was it? 3x. And we divide everything by the 3. Oh, including the original one. A lot of kids will say, well, that's smaller than 360. I don't have to divide. Yes, all of them get divided by 3. All right, x equals, what do we end up with here? 90. This one is 210. And the last one? 330. Now in your final set should be between 0 and 360. Is this between 0 and 360? Yes, yes it is. Got it? Okay. Number 2. Cosine 2x over sine x plus sine 2x over cosine x equals 1/2 secant x cosecant x. It looks a little crazy. Do you agree?
Should we change the right side to sine and cosine?
Okay, good observation. First off, does this look anything like the last one? No. You can tell this is not a condensing problem, at least not yet. It may not be at all, but it may become eventually. Okay, Justin pointed out, can we change this to sine and cosine? Again, remember that tricks to try list that we had back in the last unit? Are we still going to be using those? Yes. Okay, so I'm leaving. Oh, I'm going to continue, and I'll bring it up after. Cosine 2x over sine x plus sine 2x over cosine x equals. Now, when I change this to sine and cosine, before I do that, do you guys agree that this is one term?
Yes.
So because it's one term, can I write it as one fraction?
Sure.
Yep, on the laptop, please. Okay, 2's in the denominator. Secant is 1 over what? Cosine. And cosecant is 1 over sine. All right, it's easiest if you write it as one fraction. It's easier on the eyes. It's easier to figure out what and how to tackle the problem. Yes?
Are you going to, I don't know whether it's like the complex fraction method or...
Yes. It's very similar to the complex fraction. So we're going to clear it, is what you were looking for. The same way we did complex fractions. And how was that? We multiply everything by the common denominator. Okay, why are we allowed to do that? There's only two cases, complex fraction and an equation. Because this is an equation, a fraction equation, we can do this. Got it? All right, so we're clearing the fractional equation. What's the common denominator? 2 sine x cosine x. All right, what reduces on the first one?
The sine.
The sine. And on the second one? Okay. And the right side? The whole thing? Okay, so here I'm left with two what? Yes.
So the 2 applies to the sine and the cosine, so it wouldn't just make it sine and cosine? It would make it 2 cosine?
Yes, because it's multiplication. When you cross-reduce this piece, you're only reducing the sine, leaving behind the 2 and the cosine. And because it's held together with multiplication, it's 2 cosine x left behind. Ask me your question again.
Wouldn't the 2 only apply to the cosine if the sine cosine was in parentheses? So, like, when you say 2 sine x cosine x, wouldn't it just simplify the sine x cosine x? Because you only get rid of one sine.
Yeah, that does make sense. Okay, let's look at something like this. Because it's multiplication, let's work it out first. What's 3 times 2? 6 times 5? And 30 over 3 becomes what? 10. Let's cross-reduce. The 3 is gone, and what does it reduce with?
3.
The 3, and leaving behind the 2 times 5, which is 10. Because it's multiplication, you can reduce bits and pieces and leave behind the product of whatever's left.
The paper, so
That's it.
you want me to put it in a box or?
You can leave it on the desk. Thank you.
Okay, so if it was 2xy, then...
Same thing, yeah. So if it was 2xy, and you were, say, going to reduce the x, it would leave behind the 2y.
Okay.
Yes?
Yeah, thank you.
Mm-hmm. All right. So good question. Are we good?
Yeah.
All right. So 2 what? 2 what is left behind?
2 sine 2x.
The signs are gone. So the left
Cosine.
cosine. Cosine. Can I multiply these together if this is, are they like terms? Can I call this cosine squared if one is an x and one is a 2x? No. The same thing over here, which is what I should have brought up initially. A kid asked me in my second period, can I take a GCF out here? Are these like terms where I can take out a GCF?
No.
Are these like where I can take out a GCF? No. If there's an x and a 2x, they're not the same thing. So same thing here. I cannot multiply these together and get a cosine squared. So what am I left with? 2 cosine cosine x times cosine 2x. Yes?
Yes.
All right. Plus, is there a 2 left?
Oh, I get where this is going now.
Yes. 2. And what's left behind here?
Sine 2x.
Sine 2x and sine x. Are you okay if I write it sine x, sine 2x, only so it can look like this one over here?
Yeah.
It's not important because multiplication is commutative. Yes.
So for the first, term, I don't really understand what's going on with the sine x's. Like for the cosine x, I totally get that, but for the sines, yeah.
With the reducing part?
Yeah.
Give me a more specific question. You don't see that they're crossing out, or you don't see what's
You just have one sine x left.
That's what my question was.
Yeah, I still don't get that.
Oh, okay. I understand better what your question was. Okay.
Thank you, Alex. Thank you.
All right. So, versus, okay, and I'll throw a y in there. Okay, is there a difference? When I reduce here, because that's squared, this is gone, and I'm left with an x there. Do you agree?
Yes.
xy. Squared is different from times 2. Here, when I reduce, the x is gone, leaving behind the 2y.
Oh,
Do you
So
s-
the 2 not only, so the 2 applies to the x and the y.
Yes, because it's not, like here, the squared is only on the x.
Yeah.
Here, it's on the x, it's multiplication, so it's attached to both. Not that it's times 2 times x and 2 times y, that's not what it means. It's just when x is gone,
X times y.
right.
Okay.
When x is gone, x is gone,
okay. I see.
leaving behind the 2 and the y. Versus here, because it's squared, it left behind one of the x's. Does that make sense?
Yeah.
Okay. All right. Thank you for clarifying better to what you were asking. Yes?
Yeah.
All right. Okay. So, are we good with what's left behind? Now, who was it? Was it Jennifer that said, I see where this is going?
Yeah.
What did you see? Can you tell us?
I see the cosine formula on the way above.
Perfect. Do you guys see that we're going to condense it eventually using the cosine formula? All right. But we have to take care of the 2 first. Good job. Meg said, wait a minute. What do we do here with the 2? And what did you say?
Get out the GCF.
Take out the GCF. 2 cosine x cosine 2x plus sine x sine 2x. Now again, it does not affect these 2's here. Those 2's are still there. It's just the coefficient 2's that are coming out. Ask me a question.
No, I get it. I
Okay.
just, that's not what I was thinking. I get it.
Okay. All right. Any thoughts? What do I do to both sides?
Divide the 2.
Good job. Divide the 2.
Would
Gone.
it be minus, or like you see in the middle would be a minus, or
Right here?
yeah.
It stays positive because it'd only become a minus if I had pulled out a negative.
Okay.
But since I didn't pull out a negative, it keeps its sign. Okay. Cosine x cosine 2x plus sine x sine 2x equals 1/2. All right. Now, do you guys see what Jennifer was saying with this is the cosine function? Yes or no? Okay. So when we rewrite the cosine function, this is going to be cosine plus or minus for the a plus b or a minus b. What is a? X. And what is b? 2x and equals 1/2. Okay. Now, is subtraction commutative? Meaning, would it matter if I put 2x minus x or x minus 2x?
It would matter.
It would matter, so it's not commutative, right? So what if somebody wrote this instead? 2 cosine 2x cosine x. Is that the same thing because multiplication is commutative? Yes or no?
Yes.
Okay, plus 2, again, sine 2x, sine x. Could I do that because multiplication is commutative? So this would give me, after we got rid of the 2's, let's pretend the 2's are not there anymore. Would this give me cosine of 2x minus x?
Yes.
Which is cosine of what?
A minus B.
2x minus x is x. And over here I get cosine of what? Okay, so is that okay? I mean, why, how is that happening that I'm getting cosine x here and cosine of negative x here, and how do we address it?
Because the cosine gets rid of the negative.
Perfect. Did everybody hear him?
Oh, that's right.
Ah, good job. All right, and he is correct. So with the cosine function, even though subtraction is not commutative, does it matter because cosine absorbs the negative, is what he pointed out.
So what I don't get is where the 2 goes.
What 2? This 2 right here?
Yeah.
X take away 2x is negative 1x. There's a 1 here.
Okay.
1 take away 2 is negative 1. All right, so does everyone understand and agree with what Darren said about cosine absorbing the negative? I had a kid say it eats the negative. Think of it that way. It eats the negative, it's gone. Do you guys agree?
So we
Yeah.
have cosine
So
x.
either way, if you had a kid doing it this way and you did it this way, would you guys end up with the same answer in the end?
Yeah.
Yes.
If you remember the cosine.
If you remember, and I'm hoping you would. I'm hoping you would get this far and be like, oh yeah, I got it. Cosine of x equals 1/2. All right, how many places is cosine positive? 2, quadrant 1 and quadrant 4. What's your reference angle? Think of that first.
60.
Is it 60? Is 60 degrees one of your answers?
Yeah.
Why?
First one.
Because it's a positive, it's in the first quadrant, so 60, and then it's pretty easy. What is 60 in quadrant 4? 300. So using all your old skills as well. All right, so what I hope you remember with this problem is 1, cosine absorbs the negative, so you're good either way. What about sine? Does sine absorb the negative?
No.
So it does not. So on sine, is it important to figure out which one's A and which one's B when you're subtracting? Yes, yes it is. All right, ready to move on?
How many more questions?
3, which is long, and 4, which is long. So 2, but more like 4. Yes, quickly. Okay, sine of A equals negative 5/13. Cosine B equals 3/5. Okay, this one deserves some stars. What do the stars mean?
It's super important and it's missed often.
It's missed often, right? Not that just it's on the test, because all of this is on the test, but kids mess this up all the time. All right, so neither A or B are in Q4. That is, you are correct. This is the hint so you know where to draw it. What does Q4 mean? Quadrant 4. Before I ask the question, what was that?
I said quartile. I don't know why I said
Quartile.
that.
Quartiles. You guys did do quartiles last year, didn't
We
you?
did.
Or math
We
1?
did the box and
All right. I'm going to draw the picture before I ask the question. All right. I'm going to have you figure out quickly. Neither in Q4, so that's enough for you to figure out where to draw them. So draw your A, draw your B quickly. I'm not going anywhere. You are.
Gonzalez? I mean,
Okay. Where's A? Which quadrant?
3.
Why is it in quadrant 3? Can you explain?
So sine is negative in green and 4, but it's not in quadrant 4, so it's in quadrant 3.
Beautiful. Did you guys hear that? She said sine is negative, and this is negative, in quadrants 3 and 4, but it can't be in 4, so it's in quadrant 3. With that same mentality, figure out where to draw your cosine. Go. I'm sorry, not your cosine, your B. Grant, where's B located?
Quadrant 1,
Quadrant 1. Can you explain?
because it can't be quadrant 4, that's something impossible.
Perfect. Beautiful. Did you guys hear him? He said because it can't be in quadrant 4, and that's the only other place cosine's positive, so that leaves quadrant 1. We're good? Okay, I know this is 13. What is sine, opposite or adjacent over hypotenuse? So -5. You do your Pythagoras theorem or you know it. I'm going to write a squared plus -5 squared equals 13 squared. You do the work, or I heard the answer. What is it? 12. Good job. Now let's say you did all of this and you got A is 12. If you put 12 here and left it, would that be wrong? Yes, be careful with that because your negative's not going to come out over here. This will come out to be positive 12. But you do have to remember that this is negative. For tangent, it would create the positive, but the hypotenuse would always be positive.
No, I mean, like, that's just how you can remember.
Okay. Good, good.
And because it's in quadrant 3, so all x and y are negative.
Good job. Did you guys hear her? She's another way to think of it is it's in quadrant 3 and all the x and the y are negative, which makes the tangent positive. That's why tangent's positive here. Got it? Good observation, guys. All right, here I have 5 as the hypotenuse. Where does 3 go? Opposite or adjacent? And we are hoping you guys remember this one. 4. Okay. Positive 4? All right, now we're ready for the question. Question A. What is sine of A plus B?
I don't like these questions, Mrs. Torres.
You don't like the what?
I don't like the question that says it's one question and then it's really 8.
Didn't we do this last night?
We did. So, okay, I'm glad he pointed this out. First off, why in the heck would I star this one if this is easy review from last night?
Because it gets harder.
Because the part B is where the tricky piece is. So I'm going to let you guys do this one on your own. I'm glad he remembered. We expand. Sine is friendly or snobby?
Friendly.
Friendly. Sine of A, cosine of B. Same sign or opposite?
Same.
Same. And then sine of B, cosine of A. I'm going to have you guys use these pictures here to figure out your fractions. Do that quickly, please. Anybody tell me what sine of A is?
Maybe from
Thank you. And cosine of B? 3/5. Already given information, which is fine. We're just double checking it, and we needed to have the fraction anyway, or the pictures anyway for this piece. Sine of B is what? Good job. Opposite of our hypotenuse, which is 4/5. And cosine of A is what? All right, we do the work, which is -15 over what?
A big number.
A big number. Anybody have it? 13 times 5?
65.
65. Good job. Plus -48. Is this also 65?
Yes.
Do we like it if it's a common denominator?
Yes.
Well, we like math either way, but it's nice. It's nice when it's a common denominator. All right, negative what? Once we add 63 over 65, and reduce if possible, since it does not reduce 63 over 65. Got it? Questions? Okay. Again, why in the heck would I put stars by such an easy problem?
Because it gets harder.
It's the part B. Part B
As it gets harder.
is where the kids tend to struggle. Students tend to struggle. Part B.
This service is already messed up a lot of,
I know.
like, we're struggling.
It was the spacing. In which quadrant
Oh.
is the terminating, not terminator, terminating ray of A plus B? All right. I had kids in my morning class. What the heck is a terminating ray? Does anybody feel that way? Like it's been so long, I don't remember. Co-terminal. Where it eventually ends is correct. Okay, so let me show you what he's talking about. Back in the beginning of the school year, lesson 3-1, terminal side.
That's too long.
Yeah, look how thin that was back then.
Oh.
And now we're here in this thicker piece. Okay, so terminal side is where you end. So when you wrap around, like that's your terminal side, that's your terminal side. Once you draw your angle, wherever you end, and you come out from your origin, you draw your ray. That's your terminating ray, your terminating side, your terminal side. Got it? Okay, so in this picture here, this would be your terminating ray or your terminal side.
You go from 0 and 2.
You go from the origin out, yep. Okay, got it? Now,
Oh, but the issue is.
how to find it, right. So let's get there. Before we do, first off, you will be asked to explain.
Oh, great.
And I will tell you this. This, neither A or B or in Q4 has nothing to do with Part B at all. This was only to help us figure out where to draw the two triangles. Has nothing to do with Part B. So in the explanation part, if you put it's in quadrant 1 because blah, 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 and there's no way it could be in Q4, I would not even give you partial credit for that. You will not use this in your explanation because this is only for A separate and B separate. Does it have anything to do with A plus B? Do you agree if angle B is big enough, it could be added to A and swing it over here to quadrant 4?
Yep.
If it's small enough, it could stay in quadrant 3. Do you see that? Okay, well, we don't know, so we have to figure it out. So here are the steps. Are you ready? First off, you ask yourself, what do
I do.
what do we know
Nothing.
about, we know a lot, about A plus B? And before we figure out what we know, I want to go back to an old lesson. So write that down first.
Oh, then I really don't know that.
What do we know, or what do we know about A plus B? Everybody have it down? I'm going to come back if you don't. Okay. This is lesson 3-7 in your notebook. Everybody here on 3-7? Now, if you remember way back when, this was part 2, when we did this, I put this line here because I left it blank. If you remember that, that was not given. And we said, oh, sine of theta means sine is negative, and according to All Students Take Calculus, what two quadrants is sine negative? 3 and 4. And then you needed extra information. If cosine is positive, which quadrant do you have to be in? 4, because that's the only place where sine is negative and cosine is positive. Do you guys remember that? Yeah. So you needed these two pieces of information. The first one to narrow it down to 2 quadrants, and the last one eliminates down to 1 quadrant. Yes?
Yes.
All right. That's what we're going to use here. So, with that being said, what do we know about A plus B? That sine of A plus B is a positive number or a negative number? Okay. Do you guys agree we found that in part A? Yes? Put your phones away. We found that in part A. Is that enough for us to restrict down to 2 quadrants? If sine is negative, which 2 possible quadrants could I be in? 3 or
Oh, well.
Now, if you stopped here and said, oh, it's in quadrant 3 because it cannot be in quadrant 4, I'd mark it wrong.
Oh, wait.
Okay? Because this, again, this up here has nothing to do with A plus B. It's A by itself and B by itself. All right. Yes?
I do apologize on behalf of myself. What is it that when you said sign it does use negative, what's the purpose of that?
That's coming from this. Why is it relevant? We'll see in just a second. But where is it
Because
coming?
that's negative?
Yes.
Okay, that makes
Yeah.
sense.
So this is negative is coming from part A. So you could put a little note here as well. Part A. So if you look back at your notes, you know what we're talking about. Okay, in part A, we found that sine of A plus B is a negative number, yes or no? So which means we're either quadrant 3 or quadrant 4. Okay, now, what do we need to know?
We need to know what cosine
Good job. She is correct.
is to solve it.
You are correct. We need to know if cosine of A plus B is positive or negative. Good job, guys. Okay, do you guys agree if we know whether cosine's positive or negative, we can then eliminate to either quadrant 3 or quadrant 4? Yes or no?
Yes.
Okay, now technically, if you wanted to, could you use tangent?
I mean, technically.
Technically, yes. Why do most kids not choose tangent?
Because tangent's ugly.
Because it's the fraction, it's not as nice. But some kids like it and they go with it. That's totally up to you. Okay, so we're going to work it out here. Cosine of A plus B. And I'm going to come back here and put stars on part B so you know when you go back to study, this is a place where kids mess up. Part A, most kids can get easily. It's part B. Part B is where they struggle. Okay, expand it. Can you give me the rest of it, Justin? The rest of the expansion for cosine of A plus B?
Yeah, we have cosine A, cosine B,
Perfect.
and then we have plus, or no, B minus rather.
Okay,
Sine A and then sine B.
perfect.
That joke is the
Okay, make your fractions. And all we care about is whether it's positive or negative. That's it. We don't care what the value is, just whether it's positive or negative. So fill your fractions in.
Then those fractions, wherever they come from, that is
The same picture that we used up here. Yep. So I'll start the first one with you. What is cosine of A? Negative 12 over 13. Cosine of B? 3 over 5. Sine of A? Negative 5 over 13. And sine of B? 4 over 5. So what does this give me? Negative 36 over, and then minus negative 20 over 65. What happens with the minus minus?
add
It becomes addition. And is this a positive or a negative number?
negative.
It is a negative. So I'm going to come up here. Is this enough for us to cross one of these out? If cosine is negative and sine is negative, which quadrant am I left with? 3. Why? Because cosine's positive in quadrant 4, right? So what quadrant are we in? Q3. If you put Roman numeral, that's fine. Okay. Now, on the test, there will not be no hints whatsoever that says hint. You need to first find, you need to now find cosine of A plus B. It will not tell you that. You just need to know. What if you found cosine first? Let's say this was cosine. What would you find here? Sine. What if this was tangent that you found first? Sine or cosine. It wouldn't matter. Okay, does that make sense? So whatever you find here, if you find sine, you then find cosine. If you already had cosine first, you would then find sine. And now for your reasoning. Explain. Okay. You're going to tell me how you knew it was in quadrant 3.
In words?
In words. So anyone? Okay, hold on. Sine, he went too fast. Sine of A plus B is what? Is negative.
Negative value, whereas cosine.
It's a negative value. And cosine of A plus B equals, is that also a negative value?
Yes.
All right. Therefore, this is shorthand for therefore. You don't have to, you can write it out therefore if you want.
Did you
Yes.
make it up, or is that
No,
what
I did not
you-
make that up. That's,
Okay.
okay. Therefore,
I've used it.
Yeah.
What the
yeah,
heck?
you've used it
Actually,
before?
it's
I've used it
free, but-
before, yeah. Some of my teachers like it.
Yep. Therefore, what would we say? Therefore, A plus B is in Q, and if you put Roman numeral 3 or the number 3, I'd accept either one. Make sense? Okay, I'm going to get the worksheets out. We did not have time for the last one, so I'm just going to at least put it up here so you could see it. Does everybody have that down? While I get the worksheet out, you can just at least look at the work and see if it makes sense. Sorry, I can't get it all on screen.
Is it the same thing?
It's the same thing. It's just this one you start off with cosine, so what would you have to find later? Sine. But it's the same exact type of problem. Yes, you can walk up there and take a picture because it's not all on screen. Oh, I didn't get the worksheets out. Did I get you guys yet? No. Did anybody not get a worksheet?
Thank you. You have that one, I have one.
All right, 4 separate pieces of paper.